and have your homework out, your textbooks open to page 62. Homework out, books open to page 62. And you completed numbers 2 through 20, the even on page, or not the even, the second column, on page 61, and you did page 62, numbers 1 through 6, and that's where we'll start. Let's take a look at that first column, or second column, 2 through 20, and then the 1 through 6. Good. And the 1 through 6. Oh, I see going down right there, sorry. Blended in with the other. All right. I'm just blind, it's probably that. All right, number 1. 4/5 of the product of x squared and y. How did you write it, Gavin?
I don't know how I put this, but I put x parentheses x squared y, but in parentheses and 4/5.
So x squared y and then 4/5, both in parentheses?
Well, no. Like the x squared y in parentheses and there's 4/5 right by it.
Like in front of or behind it? Behind it?
Yeah.
So you said x squared y in parentheses and put 4/5.
Yeah.
All right, so two things are wrong here. Number 1, you never put the number after. Number 2, if you only put 1 in parentheses, you put the second one in parentheses, not the first one in parentheses. So if you had said 4/5 x squared y, I guess that would have been acceptable. Do we need parentheses though? No, just 4/5 x squared y, but that's not necessarily the best way to write it. What would be even better?
4 parentheses x.
Stop it with the parentheses.
4 x squared y over 5.
There we go. 4x squared y over 5 is the best way to write number 1. All right, well, we're off to a rough start. Though not entirely wrong, just not written best. Maybe a point off for writing it incorrectly, but it wouldn't have been a totally wrong answer. Number 2, Noah, a plus 2b divided by 32.
A plus 2b over 32.
Get a plus 2b, all of it over 32. We could put parentheses around a plus 2b, but we don't need parentheses again because we have the fraction bar this time that groups. Number 3, half a number decreased by 5. Brecken.
1x over 2 minus 5.
Good. Do we need the 1? No, so we just say x over 2 minus 5 would be the better way to write it, but nothing wrong with 1x over 2 minus 5. Number 4, the cost of n hamburgers at $1.25 each. You know that's not real beef in those. What do you get? Maddie?
$1.25 times n.
Good. And how do we show that it's being multiplied?
Well, you don't really need
Yeah, just $1.25 n. And we're good. Number 5, 3 consecutive odd numbers. Let's pause for just a moment. I want you to get your notes ready here. We need to talk a little bit about series of consecutive numbers here. So if you didn't get this one, I don't blame you. I am curious if anyone managed to think this through, but I think it's highly unlikely. If I just wanted consecutive numbers, 6, 7, 8, 9, 10, whatever, the first number could really be anything, couldn't it? And how do I show that it could be anything, class? X. X literally represents any number. I'll write that in your notes. What would be the next consecutive number after x? 6, 7, 8, 9, 10, 11. X plus 1. Now, if you add 1 to any number, you get the next consecutive number. What would be the next consecutive number, class?
X plus 2.
X plus 1 plus another 1, or we say x plus 2. What about the next number, class?
X plus 3.
All right, no more than just Noah can figure this out. Class, what's the next number?
X plus 4.
Okay, we're catching on to the pattern here. That's good. This is how we represent a series of consecutive numbers. Now, we've actually already addressed this topic of x plus 1, x plus 2 in class before. Wanted you to get it in your notes, particularly contrast that with series of consecutive odd numbers, or perhaps consecutive even numbers. I want to start with even numbers, and we're going to get to the odd numbers in a second. What makes an even number even? Why are even numbers even numbers?
They're divisible by 2.
They're evenly divisible by 2. Now, if they're divisible by 2, then that means there's a 2 in them that can divide out, correct? For instance, 8 is divisible by 2 because there's a 2 in 8, 2 times 4. 26 is divisible by 2 because there's a 2 in it, 2 times 13, right? So to show any even number, we'll take 2 times some integer. No matter what you call x, you're going to get even. Whether you make this odd or you make it even, doesn't matter. If you multiply any integer by 2, you automatically guarantee evenness, correct? So go ahead and write this down, that 2x is how we can represent any even number. Now again, by number, I really technically mean integer here, but we don't tend to think, somebody give me a number, 4/15. Okay, people don't do that, okay? Give me a number, 7, right? Okay, so we typically think in terms of integer, but I guess the better way to put this is any even integer. Now question, how do I go from one even integer to the next even integer? 4, 6, 8, 10, 12. Well, not x plus 2, 2x plus 2, right? I would add 2, so 2x plus 2 would be the next consecutive even integer. What about the next one? 2x plus 4. What about after that? There we go, Bracken, 2x plus 6. And just so on and so forth, right? This is how we represent a series of even numbers, consecutive even numbers. I'm just too lazy to write the word consecutive. That's a big word. Okay, series of even numbers, 2x, because that's any even number. 2x plus 2, 2x plus 4, 2x plus 6. Now here's the killer question that comes back to number 5. What makes an odd number odd? Can't be divided by 2. In other words, what makes an odd number odd is that it ain't even. Fair, right? That's what makes an odd number odd. Even numbers can be evenly cut in half. You can make even halves of them, called even, because they can be evenly broken in half. Odd numbers can't be, so that makes them weird or odd. Okay? So, if I wanted to guarantee myself an odd number, what might I do?
1x plus 2 is 4.
Well, 1x, so let's just say x is 6. 1 times 6 is 6, but that's not odd. How do I guarantee something's going to be odd? Pick any even number and go up 1.
3x.
No, because if x were 4, 3 times 4 is 12, that's even. So 3x wouldn't work. Take any even number and then add 1 to it. 16 plus 1 is 17. 28 plus 1, 29. 30 plus 1, 31. So take any even number, class, 2x, and add 1. You guarantee yourself an odd number. So 2x plus 1 is how we're going to represent any odd number, or any odd integer. 2x plus 1. Just barely fitting on the chalkboard there. So question, how do I go from one odd number to the next odd number? 7, 9, 11, 13, 15, 17.
2x plus 3.
Good, I add 2 to any odd number to get the next odd number. So it means it'd be 2x plus 3. What about the next odd number?
2x plus 6.
Oh my. 2x plus 5. Yeah, 2 to 3, you get 5. 2x plus 5. What about the next odd number, class?
2x plus 7.
2x plus 7. So the answer to number 5 is this right here. 2x plus 1, 2x plus 3, 2x plus 5. I'm assuming nobody got that. Okay, it would have taken a great deal of thinking to figure that out. But that's what they were looking for there. Don't feel bad if you didn't get it. I hadn't taught it yet. But does it make sense now that I've gone over it? All right, so class, if I just want any number, class, we call it x. And then the next consecutive number, x plus 1, then, if I want any odd number, 2x plus 1, then the next odd, then, but if I want any odd number, 2x plus 1, then 2x plus 3, then 2x plus 5. But if I just want any number, x, then x plus 1, x plus 2. If I want any even number, 2x. If I want the next even number, then, and then Does that make sense? How to represent series of consecutive numbers. All right, almost every year I get the class and I'm like, all right, but any odd number, 2x. No, we just said odd numbers 2x plus 1, come on. And y'all caught it. And Maddie especially, she went forward with some confidence there. Y'all are like, something's not right. What? And she's like, I'm just gonna answer the question he asked. Way to go, Maddie, bravo. All right, anyway, that was a long explanation there on number 5, but we needed to go ahead and go through that. We were going to get to that soon anyway. And so good that you get that in there. Number 6, John's age in Y years, if he's 15 years old now. Gavin? 15 plus Y more years, good. Let's go ahead and turn back. Any questions on the 1 through 6, by the way? All right, how many got all of them except number 5 correct? You got all the others right. Okay, any questions? Flip back a page to page 61, and let's go down the second column to see how we did. We began yesterday looking specifically at equations with fractions. Now, I like equations, but fractions just make things messy. How does that make me feel, class? How do I feel about fractions in my equations? How do you guys feel about fractions in your equations? Yeah, hate them, right? And how do we get rid of them? How do you get rid of them?
Please
Multiply everything by the LCD. We're going to have to drill this a little bit more. Okay, so class, how do we feel about fractions? We hate them. Okay, y'all are not a group of actors here. Hate them. Okay, contortion of the face. Anyway, so we hate them. So how do we get rid of them? Say it with me. Multiply everything by the LCD. Again, how do we get rid of fractions? Multiply everything by the LCD. So as we look at number 2, sorry, as we look at number 2, we have to multiply everything, class, by 8, which is what? 2. So when you multiply, now granted, to be fair, that one's a really stupidly easy one, okay? You could just add 1/2 to both sides to get x is 8.5, all right? But for the practice sake, right? That's the reason we're doing, for the practice sake of getting used to multiplying everything by the LCD. When we multiply everything by 2, what does the equation become, Brecken? 1 There we go. And then of course we can add the 1 to both sides to get 2x is equal to 17. And when we divide the 2, we end up with 17 halves, which is the 8.5 I said we would get. Again, kind of a stupidly easy one, but whatever. Number 5. We got a problem right up front here. Maddie? What?
We have a mixed number.
Yeah, we have a mixed number. We really, mixed numbers and algebra just don't go together. So let's get rid of the mixed number right up front.
17 and 14.
17/14 is equal to k plus 5/7. What's the LCD this time, Maddie?
14.
And we're going to multiply everything by 14. Now, might sound a little silly the way I say everything, but as we noticed yesterday, sometimes we forget to multiply everything by the LCD, and that's the reason why I emphasize it that way, in hopes that as you're working, you'll be like, fractions, I hate fractions, multiply everything. Oh, everything, that's right. That's kind of the hope. Doesn't always take, apparently. But it's okay, it was day 1. We're not a little betterness, no upset. We're going to get there. All right, so when I multiply everything by the LCD, Maddie, what do I get?
17 equals 14k plus 2.
Good, because the 7 and 14 cancel, give me 2, and the 2 14s cancel plainly. All right, from here, of course, we can subtract the 10 from both sides to get 7 equals 14k. Divide away the 14, and end up getting what answer here, Maddie?
Negative 1/2.
Negative 1/2. 17, negative 10, positive 17, negative 10 gave you a negative 7. Keep the sign of the greater. Should have been a positive 7, so positive 1/2 should have been our answer for k on that one. Number 8, there was only one fraction in the whole thing, and I'll be honest with you, on number 8, I probably wouldn't multiply everything by the LCD, just me being me, because when you combine all your x's together, Noah, what do you get?
7.
negative 1x, right? Negative 5, when you group the negatives, you got the positive 4 gives you a negative 1x. So that gives me negative x equals 3/8. What did I say to do when you get a negative x, class?
Negative.
Change both sides. Boom. There we go. And so that one there, we really didn't need to multiply everything by the LCD, but you could have multiplied everything by the 8, I suppose. How many got negative 3/8 for your answer? All right, as a reminder, negative x, change the signs, and that'll knock out the negative. Technically, you're dividing away the negative 1, but I'm too lazy to show that when I can just change signs, right? Easy way, always better. Well, almost always better. Number 11, right up front, Gavin, what do we got to do with this thing? Not yet. Look at number 11 in your textbook. This is why the book's open.
Mixed number.
Mixed number, change it into, which is 3x over 2. And we got the negative 1 all equal to 2. Now we can, and when we do, we get
3x negative 2 equals 4.
there we go. Again, a lot of these equations I'm noticing we only have 1 or 2 fractions in there. Really not too hard. We're going to get to ones that have more fractions as we go. But now what, Gavin?
You add a positive 2 to both sides.
I'm going to give you 3x equals 6, so x just equals 2. And there's our answer on number 11. How many got that for number 11? Any questions on the first 4 homework problems, 2, 5, 8, and 11? How many perfect on the first 4? Perfect on the first 4. How many just missed 1? We understand the things we should have done. Okay, let's take a look at the last 3 then. Number 14. Personally, I don't like big numbers like 17 and 30. So I would go ahead and get rid of that 17 just right up front, Brecken. Big numbers scare me because I'm lazy. Big numbers usually mean hard work, and I don't like hard work. So let's get rid of the 17. What? How do I get rid of the 17? I subtract the 17. I'll put a negative 17. Now, just be careful with your borrowing. There we go. So with 1x over 2 is equal to 13. And now from here we can go ahead and do what? And multiply everything, which is both sides. Pi the LCD, which is 2. And when I do, I get what? 2 times 3, 2 times 1, 26. And there should have been our answer, x equals 26. Now, if you had the wrong number here, then that would have led to the wrong number later on. Number 17, finally something that's a little bit more involved, I suppose. We have a 2/3 x plus a 1/2 x, negative 6, all equal to 8. And I suppose if we wanted to, Gavin, here, we could do kind of like what we did here, just get rid of that 17. We could get rid of that 6 first if we wanted to. I mean, did you or did you not? You did not, that's fine, you didn't have to. What's the LCD here? Because we finally have multiple fractions. 6. And we need to multiply everything by 6. All right, and so when we do, what doth we get?
4x plus 3x negative 36 equals 48.
There we go. Remember the 6 and 3 cancel to give you 2. 6 and 2 cancel to give you 3. That's where you got 4x and 3x. 6's don't cancel. This is not a denominator 6. It's a numerator 6. We can combine like terms here, Gavin.
7x.
Negative 36 equals 48. And then Noah, we can get rid of the negative 36. And big numbers. And I get what? 84. Fortunately, that divides evenly by 7 if we recall our 7 times tables, and we get x equals 9 times 7 equals 63. 12 times 7 equals 84. All right.
Get on to your 3rd grade teacher about that.
Anyway, number 20, our last one. There is a bit of a shortcut that we could use here, and I'm gonna go ahead and show that to you because I like shortcuts. That big old ugly 5/2 there, you realize I could get rid of that 5/2 just like that. It's being multiplied by this whole quantity. I could divide, or rather, we don't really divide fractions, Maddie, we.
Multiply by the reciprocal.
So if I multiply both sides by 2/5, because this side is all grouped as one entity anyway, I can do this and multiply the other side by 2/5. When I do, 10 and 5 cancel to give me 2 and technically 1, giving me x plus 3 all by itself now is equal to 4. When we put a -3 on both sides, what did x equals? 1. And there's our answer. Now, again, if you didn't do that, it's perfectly fine. We could have just multiplied everything by 2. And when I do, then the 2's cancel, which would leave me with 5 times x plus 3 is equal to 10 times 2, which would have been a 20. I could have distributed the 5 then to get 5x plus 15 equals 20. I could have subtracted the 15 from both sides to get 5x equals 5, and then I get x equals 1. So a couple of ways in which you could have approached that, but I wanted to show you, since the one side was all grouped as one thing anyway, you could multiply by the reciprocal and knock out the fraction that way. Here, could have done it, right? This is all different terms, it's not all grouped together. I had to take care of each term separately. But there, a little shortcut we could have used. Questions on that last one? I'm presuming most of you would have done it this way, but I wanted to show the other way in case you understand. If you don't understand it, that's fine, you don't have to. But if you can benefit from the shortcut. Questions on these last three, 14, 17, 20? Going once. Anyone perfect on all three? Got the right answer on them all? Question? All right. Turn over, page 62. Page 62. I want you to do numbers 8 through 20 to even. 8 through 20 to even on the next page, page 62. Normally I would get you to the board right now. Check your answers to 8, 10, and 12. Number 8, I mean, just multiply both sides by 3 to get 27. I assume we're good on number 8. Again, 27 should be your answer. Number 10 should have gotten -4. Number 12 should have gotten 7. How many good on those first 3? All right. Maddie, which one do you need me to leave up, or do you need both of them left up?
12.
Just 12. Okay, I'll leave 12 up for you for a minute. Check your work, see if you find a mistake. If you can't find it, I'll come help you. Find it, Maddie? Once you finish 18, check your answers to 14, 16, 18. Once you finish 18, check your answers on 14, 16, and 18. Okay. Maddie, good on all 3 of those? Yeah, how'd you do? Got them all? Finish out 20 then? And Brecken good on all 3? Excellent. Yeah, we're good to go. And Maddie found a mistake. Gavin? What'd you do, Maddie?
I put a positive 9, but then when I went to go, and then when I went over to 14, I wrote a -9.
So you put +9 here, but what you do to one side, you didn't do to the other, and so you end up with a 5x, so you got like 23/5 or something weird, okay? Gavin, what'd you do?
For some reason, I had it -7, -x on accident.
Oh, you try to combine unlike terms together and got 7x right here.
For some reason, I got positive 3x next to negative 7x, and for some reason I thought there was accepted negative 7.
So you just combine all of this together and wound up with, let's see, 16x equals 16, which still would have given you a 1 actually.
Yeah, what happened is I still crossed out the 3 thing, it was negative, because it's something X later on.
Okay, alright. Brecken, how'd you do on this one? Good to go? Alright. Flip back to page 61 now. Back to page 61. Do 12, 15, and 18. Page 61, 12, 15, and 18. Go back to some practice with fractions again. Again, what's the key here, class, to getting rid of those fractions? Multiply what, Noah? Everything by the LCD. So class, thank you, Noah. Class, what's the key to getting rid of the fractions? There we go, multiply everything by the LCD. Noah, good to go? Maddie, good to go? Just another minute to finish up. Once you finish, check your answers. Gavin, good to go? Brecken, let me have you stop where you're at. Did you get the first two correct, 12 and 15? All right, let's see where you're at on number 18. Now, you'll notice I went ahead and combined these into a single value before multiplying everything by the 12. It just made things a little easier. I didn't have to get an 84 and a 36 and then combine them together. You get the same answer either way, but a little bit easier. Did you multiply everything by 12? Okay. Did you get an 8x and a negative 9x on this side? All right. And so that would have combined for a negative 1x. Notice here, class, I've got negative x and negative 48. Just change both signs. X must equal 48 for our answer there. Any questions on these? All right. Next thing in your notes. There's I hate fractions, right? But there's a faux fraction, an undercover fraction that you talked about really going back to elementary school, and that's a decimal. It's just a fraction in disguise. But in a way, a decimal doesn't seem quite as bad because decimals are always tenths, hundredths, thousandths. They have nice, easy denominators to work with. But decimals, I don't like either. So next section in your notes, clearing decimals from equations. Clearing decimals from equations. Clearing decimals from equations. Here's your first step in clearing decimals from an equation. Step one is to identify the number of places in the ugliest decimal. Identify the number of places in the ugliest decimal. You understand that the bigger the decimal gets, the uglier it gets, right? Like 0.7 seems so harmless and innocent, but 0.7314 is just really absurdly ugly. This is the uglier decimal. So if we had an equation, this isn't an equation that we're actually going to solve because I don't know how it would turn out, but if we had, 0.05x plus 3.274 minus 0.1 equals 5 plus 2.7x. All right, this was our equation. Which decimal is the ugliest one here, Gavin? Yeah, how many identified? Yeah, that's the ugliest decimal. It's not a mathy way of putting it, but that is definitely the ugliest decimal because there's 3 places. That's your first step, is just identify how many places in the ugliest decimal. And then, step 2, move every single decimal point that number of places. Move every single decimal point that number of places. Move every single decimal point that number of places. So in this little equation that we're not going to take time to solve, we would have to move the decimal 3 places in everything. Once you've got it written down, observe. Move it 3 places. Well, moving it 3 places here is easy. 1, 2, 3. Decimal all gone. That's the whole point, right? To clear the decimals out. Gives me a 3,274. But right here, watch when I move it 3 places. 1, 2, 3. There's not a third digit, is there? And if there's not a digit, that's okay. You fill it in with a 0. I now have 050x. That's a really weird way of putting it. We don't need the initial 0. We'll just say 50x. So right here, 1, 2, 3, both gaps need to be filled in with zeros. So it's really a negative 100. Ooh, look at the 5. There's not even a decimal in the 5. Where is the decimal, class? It's after the 5. So if I move it 1, 2, 3 places, all 3 places have to be filled in with zeros. So I basically just get 5,000. And here, 1, 2, 3, I'm going to need to add, class, 2 zeros to get 2,700x. This is why we're not going to solve it. Okay, it gets pretty gnarly there because of the huge numbers and all. But I don't have to worry about the decimals anymore. I'm dealing with integers again. Nice, easy whole numbers. Now, how does this work? Why is it that you can multiply or just move the decimal over 3 places? Because technically, I'm multiplying by 1,000, right? If you move it 3 places, that's thousandths. So by moving it, it's as though I'm multiplying everything by 1,000, as long as you do it to everything, like we multiplied everything by the LCD, it's really the same thing. My LCD is 1,000. Had 2 decimal places been the ugliest, I'd be multiplying everything by 100. But I don't think of it that way, I just move the decimal twice. If everything only had 1 decimal, I'm multiplying everything by 10. But I don't think of it that way, I think of just moving the decimal once. Write this down on your paper. 0.2x plus 3.2 equals 1.8. Again, equations are fun, equations are easy, and then decimals come along and make it hard. So I don't like them. So I get rid of them. And in this particular equation, how do I get rid of the decimal, Noah? Move the decimal one place everywhere. And this time it's really easy, because we move it one place everywhere. What does my equation become, Noah?
2x plus 32 equals 18.
There we go. Now I've got nice, ordinary, common numbers again. Where to solve, class, I would need to put a negative 32. Now let me put, I got a 2x equals, let's see, negative 32, positive 18. Let's put the negative 32 above the positive 18, make it easy to borrow. 14, but which sign? Negative 14. And now x equals, class, negative 7. Questions on that problem? You 3 should remember this from junior high, right? You learned this both 7th grade and 8th grade. Brecken, have you ever seen this before? All right, does it make sense to you? All right, let's do another one. Write this one down. 0.4x minus 6 equals 0.2x. 0.4x negative 6 equals 0.2x. First thing I want to do, Brecken, is get rid of my, and how many decimal places do I need to move it everywhere? Once. So here I move it once and I get 4x. Here I move it once and I get a negative 60. Fill in the gap, if you will. And then here I move it once, I get 2x. And that was just a nice, ordinary, everyday equation. Where, class, we need to, here, there's an x on both sides, right? So get rid of the little one, which is the 2x. Maddie, if I subtract away the 2x, what is left on the right-hand side? 0. How about on the left-hand side? Brecken? What do I need to do now, Brecken? And that'll give me a 2x equals 60. So x is equal to 30. Once again, thank you, football. 60-minute into 30-minute halves. All right, see, sports are great for learning math. They really are. Anyway, for instance, you know, if you're watching and you're like, you know, it's 1st and 10, took a 3-yard loss. 1st and 13, practicing your addition skills, right? 7-yard gain, 2nd and 3, practicing your subtraction skills. See, it's great. You know? Anyway, you know, let's see, we were at the 42-yard line, and the guy caught the ball at the other 47-yard line. 8 yards and 3 more yards, 11-yard gain. See, it's so much math. Football's wonderful. No wonder I love it so much. It's so educational. That's what I tell my wife. Are you watching football again? I'm learning, dear. I'm keeping my math skills sharp. I'm a math teacher. This is necessary preparation for me. Must watch lots of football. I watched about a quarter of last night's game, and then I was tired and went to bed. But anyway, I don't know the dog in the fight. Questions on this? Let's do one more. I'll write this one down. 1.3x plus 2.04 equals 7.24. At your seats, do the first step. At your seats, do the first step. And Gavin, what do we write down for our first step? What?
No, that's not right.
Just say that again?
It's 130.
130x?
130.
Oh, 130x. I knew you didn't say and. All right, keep going.
Positive
decimal 2 places, add the 0, 2 places, no zeros needed, 2 places there. How many have the initial step correct? Solve. And what is 52 divided by 13, class? 4. Be our answer. Questions on clearing decimals. All right, we're going to practice more with decimal clearing on Monday in our next lesson. This evening for homework though, not a lot of fractions, decimals to worry about, just some basic equations to practice with. Don't want to take up too much of your time once you'll be able to spend this time keeping your math skills sharp while you watch football. So your homework is to do page 62, numbers 7 through 19, the odd. Page 62, numbers 7 through 19, the odd. No watching football till your homework's done. This is part of my homework. Ms. Jesky said I was supposed to. See, it's in my assignment pad. I wrote it down. Watch football and keep math skills sharp. All right, have a wonderful rest of your day. When the bell rings, you will be dismissed.